Hello everyone, I'm Eric Zhao, and today I'm gonna solve a few questions from MCR4U1 Unit 1 and 2 Vector. A fury ball across the river and arrive at a point on the opposite bank directly across the straight point. The ball can travel 4 meters per second and the current is 1.5 meters per second. If the river is 650 meters wide and at the crossing point, in what direction must the ball steer and how long it will take to cross? Alright, so first we're going to start off with drawing the graph. So as you can see right here, it is 650 meter wide and the current is 1.5 meter per second going down. And this is our boat traveling at 4 meter per second in this direction. So now we're going to solve angle B because what we want to know is the boat steering direction. So actually it's pretty easy. So we use a sign in the right triangle, which is sine to the negative power of 1 times 1.5 meter per second over 4 meter per second is equal to 22 degrees. So the direction of boat steer is east 22 degree north. Alright, then we're gonna solve how long time it takes to travel from this side to this side. So actually it's pretty easy. It's solving the distance from here to here. Alright, so as we know, the river is 650 meter wide, and we know angle B is 22 degree right here. So actually we can use cosine law. This is 650 meter, and we set up this side as x. So as you can see right here, cosine 22 degree is equal to 650 meter over x. So x is equal to 650 meter divided by cosine 22 is 701 and 0.05 meter. So the time is equal to distance divided by velocity. As we know, the boat travel at 4 meters per second. So it's 701.05 meter divided by 4 meters per second is 175 and 2 seconds. So it will take 175.2 seconds to cross the river. Alright, so now we're gonna start the second question. A steel cable is 40 meters long and is suspended between two fixed points 10 meters apart horizontally. The cable supports a mass of 50 kg at a point 6 meters from one end. Determine the tension in each part of the cable. Alright, so let's start with drawing the diagram. As you can see right here, one end is 6 meters, and as we said, the total length of the cable is 14 meters, so this end is going to be 8 meters, and we have a 50 kilo object right here. We have a force going down, which is the force of gravity. We also have a force going up, which is the equivalent, which is the force to support this object due to Newton's third law. So now we're gonna calculate the tension. So some of you guys make a mistake pretty frequently, which is you think this side is longer, so we have more tension, and this side is shorter, you have less tension. But actually it's not. It's the opposite. Because this side is longer, it has less tension, and this side is shorter, it have a higher tension. So we have to draw a diagram like this. So this is equivalent, and we do a 90-degree angle here and a 90-degree angle here. And this is actually the tension 1, and this is actually tension 2. As you can see, the 1 is smaller than 2. So now we're going to start solving this question. Triangle ABC is a right triangle, since 10 squared is equal to 6 squared plus 8 squared. It's 36 plus 64 is equal to 100. And sine angle 1 is equal to 6 meter over 10 meter is equal to 0.6. Sine angle 2 is equal to 8 meter over 10 meter equal to 0.8. Force of gravity equal to mass times g equal to 50 kilogram times 9.8 Newton per kilo. It's equal to 490 Newton and is also equal to the equivalent. So as we can see right here, we are using angle A to solve the tension. So the tension is on the opposite side and this is the hypotenuse. We knew the hypotenuse is the equivalent, which is 490 Newton. So it's going to be pretty easy to solve the tension. So tension 1 is equal to sine angle 1 times 490 Newton, which is 0.6 times 490. It's 294 Newton. Tension 2 is equal to sine angle B times 490 Newton is equal to 392 Newton. So the question solved. The tension of 6 meter is 294. The tension of 8 meter is 392 Newton. Alright, so now we start with the third question. What is the relative velocity of an airplane traveling at a speed of 735 knots on heading of east 70 degrees south with respect to an aircraft at the same height steering west 50 degrees south at a speed of 300 knots? Okay, so let's look at the diagram first. As we can see right here, this is for direction. And first we have 735 knots going east 70 degrees south and 300 knots going west 50 degrees south. So what we're trying to get is right here. So basically you connect the top point of two velocity, which is here, and this is their relative velocity. But actually, the relative velocity here, you cannot get what direction it's heading if you don't draw a cross right here. So actually, I moved the parallel to right here. So it makes me much easier to get this angle for the degree that it's traveling. So first, we start with cosine law to get the velocity r. So a squared plus b squared minus 2 times ab cosine angle c is equal to c squared. This is the cosine law, and so on 300 squared plus 735 squared minus 2 times 300 times 735 cosine. Because right here, this is 180, this is 50, this is 70. So I have this right here, which is equal to 60, is equal to r squared. As you can see, so on and so on, and in the end, r is equal to 640.1. If you don't mind, you can don't write the 0.1 right here, it doesn't really matter. And now we get the r already. So we have all three velocity right here, and now we need the angle, which is this angle. Because as we can see right here, this is the 70 degree. And what we are trying to get is right here, the angle alpha. Which we had to get this angle and this angle, so we can get the angle alpha. Because this is parallel. So this angle and this angle are the same. So we just need to get this angle. We know this is 300 knots, and we know this angle is 60 because we mentioned right here, and r is equal to 640. So we use sine law. Sine x is equal to sine x over x equal to sine angle y over y. So sine angle 60 over 640.1 is equal to sine this angle over 300. So sine 60 times 300 divided by 640.1 equal to 0.4. sine to the power of -1 times 0.4 is equal to 25 degrees. So this angle is 25 degrees, same as this angle. So now it's going to be pretty easy to get what is angle alpha. It's 70 minus 24 degrees is equal to 46 degrees. So the relative velocity is 640.1 knots and east 46 degrees south. Alright, that's all of the question that I'm talking about today for Unit 1 and 2 vector for calculus. Alright, guys, have a good one. Hopefully, these questions help you to prepare the test and other stuff. Bye.